Let us do a lab activity on refractive index of the prism. Click each tab to learn more. The aim is finding the refractive index of the prism. Materials required are prism, wooden plank, white chart, pencils, pins, protractor and a scale. Take a wooden plank which is enveloped by a white chart. Take a prism. Place it on the white chart. Take a pencil and draw a border line along the edges of the prism. Remove the prism from the chart paper. Now we obtain a triangle. Mark the vertices of the triangle shape as P, Q and R. The refracting surfaces could be rectangular in shape. Measure the angle between PR and PQ. The obtained angle is called the angle of the prism A. Now mark a point M on the PQ surface of prism. Draw a perpendicular line to the surface PQ. Place the protractor origin at point M along the normal line. Make an angle of 30 degrees, then draw a line up to the point M and also draw a small arrow on it. This line represents the incident ray. Hence, the angle between incident ray and normal line is called angle of incidence I1. Once again, place the prism on the boundary PQR. Now take two pins and pin them on the vertical line at some points, say A and B, which are already drawn. Looking to the other side, fix two more points at some points, say C and D, in such a way that all the four pins appear to be in same line. Remove the prism and also pins and mark their positions. Draw a line to join the points C and D. Extend the line to meet the surface PR of the prism at point N. This line denotes the emergent ray. Draw a perpendicular line to the surface PR which acts as normal line. The angle between the normal line at point N and the emergent ray is called the angle of emergence I2. Find this angle and note it down in a table. Now join the points M and N by a straight line. Thus, the line passes through the points A, B, M, N, C and D. This line denotes the path of light when it suffers refraction through prism. Extend both incident and emergent rays until they meet at a point, say O. Here the angle between these two rays, called angle of deviation D. Find this angle and note it down in a table. Repeat the same procedure for different incident angles, such as 40 degrees, 50 degrees, etc. Find the corresponding angles of deviation and angles of emergence and note them in the table. Draw graph by taking angle of incidence along x-axis and angle of deviation along y-axis. From the graph, we observe that the angle of deviation decreases initially and then increases with increase of the angle of incidence. The tangent to the curve at the lowest point of the graph and parallel to the x-axis cuts the y-axis at a certain point. This point is called angle of minimum deviation, denoted by D.